Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, buy 2 chocolates. So basically we have an integer array with prices. And the prices basically represent the prices of chocolates that you have in a store. And you have some money. And the goal is to buy 2 chocolates such that the remaining or the leftover money you have is positive or equal to 0. If it will put you under, so if it would make what you have left over negative, which means put you in debt, you don't want to buy them. And the goal here is to minimize also the sum of the price you will pay. You have the array of prices, so you need to pick the 2 chocolates with the minimum possible sum, so the 2 smallest ones. And if there is no way to buy without ending up with negative leftover, then you can just not buy them and return the remaining money, which would be the entire value of the money. Okay, so that's the idea. Pretty straightforward. The easiest way, of course, to solve this is to just sort, take the 2 smallest ones and then see how much you have left, right? So let's do that. So that would be the easiest solution here, is to just take prices, sort them out, and then take the sum of the 2 first smallest ones. So in Python we can do it like this. And so this would be what we buy, and then the leftover would be just the money we have minus what we need to buy. Okay, and then we need to return leftover if, of course, it's positive. That's what the problem says, because if it's negative, then we won't buy anything and we'll just return the entire money we have, right? So pretty straightforward solution here. Let's just run it and see if it passes. It looks good. Let's submit. It looks like it passes. Okay, now since this example was pretty simple, let's do a couple of things just to exercise what we are doing here. So one thing we can do, so this is equivalent to getting the sorted prices. We will get back a sorted list. We could do it like this, but we can also we want the 2 smallest ones. So in Python you can do this thing where you can get an element, right, and then get the rest. By using star, you can get the rest in this array. So the first element would be in this variable, and then the rest would be here. Okay, and so we can do something like that, where the first min would be this one, the second min would be the second one, and then the rest of the array would be in this rest array. Okay, and now to know what to buy, what are we buying? Well, it's just the first min plus the second min. Okay, now the other thing is, since we don't need actually the rest variable, we won't need to use it at all. We can just put underscore here. In Python you could do that if you are not using a variable. And this destructuring now will work, will give us the smallest one here, the second smallest here. And now you just subtract that from the money and you have the leftover. We still keep the same thing. These two, we keep them the same. Now if we run this, looks like it's good. Okay, so it got accepted. We can also just put this here, because this is easier. And this works. Now we did this with sorting, which is of log n. Okay, of n log n sorting. Now can we do this in O of n? Which should be doable, because we just need to find the first min and the second min, right? And so let's do exactly that. So in a way that we don't sort. So to do that, well, let's just initialize both as a large value, so that we can min them with anything and get that value. And now we'll just go through the prices. And we'll check if the value is smaller than first min, then we have a new first min, right? I think this is easier if we call a list second smallest. I think that would be easier. Okay, and so if this is the smallest, then we can just assign p, make that be the value here. But the second smallest now becomes this one, right? Because this one is greater than this one. Now we find one that is smaller than this one, so this one becomes the smallest and this one becomes the second smallest, right? So the smallest will become p, but the second smallest will need to become smallest. Okay, the reason we are the reason we are doing those two in the same line in Python is important because we don't want to override smallest first and then assign it to second smallest, right? If we have to do that, we will need to use a temporary variable, but it's just easier in Python to do it in one iteration. So we'd have second smallest, we'll assign smallest, and then for smallest, we'll assign p. Now, otherwise, if p is not smaller than the smallest one, but is smaller than the second one, then the second smallest should now be equal to p, right? And that's pretty much it. Now we just need to use these two here, and the rest should stay the same. It looks like this is good. Let's submit and it got accepted, right? Yes, so pretty straightforward solution here. This one is oven compared to the previous one. Yeah, so that's pretty much it for this problem. Thanks for watching. If you need help, get in touch with me from the link below using SuperPeer, and see you on the next one. Bye.